I'm Anil Kumar. Welcome to my series on rational functions. We'll begin with understanding of rational numbers, then move on to rational expressions, talk about restrictions of rational expressions, review few basic concepts of factoring polynomials, then we'll simplify rational expressions, stating their restrictions, and then we will see how do we multiply and divide rational expressions and how do we add and subtract rational expressions. So let's begin with rational numbers. As you know, rational numbers basically is quotient of integers, right? So whenever we have quotient of integers, that means one integer divided by the other, we get a rational number, right? So it's a quotient of, you can say, integers. So basically, you can say that a rational number q is basically a set of all numbers where x is of the form of a over b, right? Where a and b are integers. So that is how you can actually define rational numbers, right? Very similar to this is rational expression. Now in this case, we have quotient of polynomials. Correct. So a rational expression, let me write like this, a rational expression can be written as quotient of polynomials. So we have something in the numerator, one polynomial, and the other polynomial in the denominator. And of course, when you have something like this, denominator cannot be 0. So we say q of x is not equal to 0. Clear? So as you have seen here, in integers, we don't really have any instructions, any restrictions on the denominator. They are numbers. You cannot have 0, right? Of course. So let me write down here. The restriction here is that b is not equal to 0. Now that 0 is not allowed for b, but all other integers can take the place of b. Now in case of rational expressions, the polynomial cannot be 0. The value of the polynomial cannot be 0, right? So that becomes the restriction. So that is how we come to this topic, which is extremely important. Restrictions of rational expressions will be, as you've seen here, we say denominator is not equal to 0. Clear? So that is how you figure out all these things. Now, how do we find whether denominator is 0 or not? Normally, these are given as polynomials, as you've seen. So we may have to learn some techniques of factoring to find whether the denominator is 0 or not. So let's take some examples, right? So for example, if I have 10x minus 5 over, let us say we have 2x plus 1. Now, in this particular function or a rational expression, let's call this as our rational expression r of x. You see the denominator is 2x plus 1. So we can equate this 2x plus 1 to 0 and then find what could give it as 0 value. So you can isolate x and we say x is equal to taking 1 on this side and then dividing 2 by 2, we get minus half. And therefore, we can say for this the restriction is that x is not equal to minus half. Clear? Now let's take another example just to understand this part. let's say we have another function f of x, which is given to us as a rational function. So where the denominator is x squared minus 1 and the numerator is x plus 1. Well, we can actually factor the denominator. So once you factor the denominator, what you get here is we get x plus 1 times x minus 1. Numerator is x plus 1, correct? Well, you can of course cancel these. Now let's talk about restrictions for this example. The important thing here is we have cancelled and we could now write this as 1 over x minus 1 since this portion got cancelled. Think about a parallel thing in rational numbers. For example, if I have 9 over 12, we could actually divide them both by 3, for example, and write this as 3 over 4. Now these are equivalent rational numbers. However, in the case of rational expressions, if we write like this statement will not be quite true. The important thing to note here is that in the function given, we have two restrictions, and that is x is not equal to plus and minus 1. But if I leave it at this stage after cancelling 1 over x minus 1, in that case, we see that there is only one restriction. And therefore, to write this as an equivalent rational expression, we have to include the restriction that x is not equal to plus minus 1. Is that clear to you? Correct? So, you have to note that, let me put it in a different ink, that you have to write restrictions before cancelling the common factors. So I hope this part is absolutely clear. Right, so whenever you write your equivalent rational expression after cancelling the common terms, include all the restrictions which were originally there in the function. Only then they will be equivalent algebraic expressions. Right, so that brings us to the main topic, which is equivalent algebraic expressions. Correct? Now let's practice few examples and review the factoring of polynomials. So here are 8 examples. They're kind of different types, but they will help you to review what you have already learned. So let's begin with the very first one, which is x squared plus 16x plus 63. Now this is a trinomial. To factor this, we are looking for product and sum. So here we need product of two numbers p and q to be equal to 1 times 63, which is 63, and sum of these as coefficient of x, which is 16. Well, the two numbers will be 7 times 9, right? So the two numbers which work for us are 7 and 9, correct? When you multiply them, you get 63. When you add them, you get 16. And therefore, we can actually write this as x plus 7 times x plus 9. Clear? Now let's take another example which is of similar kind. So we have done part A. Now in B, the example here is a squared minus 4a minus 45. Now again, going with the same principle of product and sum, we are looking for product of two numbers to be equal to negative 45, correct? And the sum of two numbers to be minus 4. So 9 times 5 can give us this result, and since one of them should be negative, since the product is negative, bigger number is going to be negative, right? 9 times 5 is 45, and that gives us minus 4 when you add them. And therefore, it could be factored and written as a minus 9 times a plus 5. Clear? So if there is a trinomial where the coefficient is 1 of the leading coefficient is 1, then directly you can write down the answer. There is no need to decompose the center term, right? In part C, we have 2x squared plus 7x plus 3. Here we have to decompose 7, so that will add 2 more steps, correct? Let's see how to factor that. So as I was saying, we have now 2x squared plus 7x plus 3. We are looking for product of two numbers to be 2 times 3, which is 6. And the sum of these two numbers should be 7. So now the numbers should be what? 6 times 1, right? When you add them up, you do get 7. So in this, we'll have to decompose 7x into 2 parts, 6 and 1. Then we'll have 4 terms and then we'll factor. So we can write this as 2x squared plus 6x plus x. Now 6x plus x is also 7x, correct? Plus 3. And now we can common factor between these two is 2x. So we have x plus 3. And here we have x plus 3 already. 1 is common between them. So we can now take x plus 3 as a common factor and write this as 2x plus 1. Clear? So that is the factored form. Now this is called difference of squares, right? So in difference of squares, you could straight away use the formula a square minus b square is a plus b times a minus b. 4b square means it is 2b whole square, right? And 9 is 3 square. So we could factor and write this as 2b plus 3 times 2b minus 3. Clear? E is very similar to D. I'd like you to pause the video and solve this. Now here, the only thing is that we have kept minus first, right? If you want, you can think like this. You can think like 121y square minus 36x square, right? Not because of exactly difference of square as we are used to looking at, right? So this is 11y whole square. So that is the thinking process, right? 6x whole square. So we see it is indeed a difference of squares, and so it could be factored as 11y plus 6x times 11y minus 6x. Correct. Now, alternate way could have been that you could have written the question here as minus outside, and then it becomes 36x square minus 121y square, right? And then you can continue. And then what result you will get here will be writing minus outside means you will just flip this portion, right? You could have written this as minus outside. So let me write 6x plus 11y. Things don't change here, commutative property. But here you could write this as 6x minus 11y. So you could do like this. Is that clear? But either way, it is the same answer. Perfect. The next example here is p cube minus p. Now it is tricky. You can actually common factor is p, so factor this out. You get p squared minus 1. Now whenever we are saying factoring, it is qualified with the word fully factored. So that is the major thing. Fully factor means you have to write down until all the factors have been taken care of. If you leave it at this stage, it is incomplete, since p square minus 1 can be further factored. So what we get here is p plus 1 times p minus 1. So that is again difference of squares. Perfect. Now, on factoring, these are the last examples. They're slightly difficult. I'd like you to pause the video and then answer these questions. Now here we have last 2 examples on factoring. We'll learn, rather review, the techniques for factoring here. two other techniques. So here we have four terms, x cubed minus 4x squared minus x plus 4. We can actually group them into two each, right? So once you group them, you do notice that we have x squared common in the first two. So we could get x minus 4. We can take minus common here and we get x minus 4. Now, x minus 4 is common, correct? So x minus 4 is common. So we get x squared minus 1 as our factor. Now, as I said, we have to fully factor. X squared minus 1 can be further factored. So we get x minus 4 times x plus 1 times x minus 1 as the final result, right? So that is how you will be factoring this. The last example here again has four terms. However, the technique of factoring is slightly different. Now you see, we have these three terms, which is a perfect square. This is 3 squared. 2 times 3 is 6. Perfect. So that is a perfect square. So you could actually write this as x squared minus, and within a bracket, I'll write these three terms, which is y squared minus 6y plus 9. I changed all the signs since I've taken minus outside. Correct? So what we get here is x squared minus. Now that is a perfect square. So we could write this as y minus 3 whole square. Correct? This is 3 squared, this is 2 times 3, and this is y squared. Perfect. Now we can again apply difference of squares method. So we have these two difference of squares, right? So first term is x, the other term is y minus 3. So factor like this, correct? Times x minus. So when you do minus, you have to change both the signs. So it becomes kind of like this. Does make sense to you? And that is your answer. So that is how we could actually factor these. So I hope with this you've learned the factoring techniques. So we talked about difference of squares, perfect squares, and their combinations with these videos, with these examples. Now, let's get back to our rational expressions. So we have two rational expressions here, and the question for you now is to simplify rational expressions. How do we do that? Well, of course, we need to factor first, and that's why we learned those techniques. So the first one here, let me rewrite this. It is x squared minus 5x plus 4 divided by 3x minus 12. The numerator, we could do product and sum. That trinomial can be factored. We need product of 4, sum of minus 5. And therefore, it could be written as x minus 4 times x minus 1. So when you multiply, you do get positive 4. When you add, you get minus 5. In the denominator, we have 3 as a common factor. So we get 3x minus 4. So now, in this simplify rational expressions, we kind of are in a position to simplify it. Now, let me add here and state restrictions. At this stage, we can always cancel x minus 4 and x minus 4. And once we do that, we get x minus 1 over 3 as the rational expression. Now 3 is also a polynomial. Perfect. Now whenever you do this, you have to state the restrictions also, right? This is not equivalent to the given rational expression, since here there is no restriction, but in the question given to you, the restriction is there, which is x cannot be equal to 4. Since we cancelled it, we cannot ignore it, right? We have to include this in our answer. Only after you include this, it becomes an equivalent algebraic expression. Is that clear to you? Now let's do the next one. Here we have 4y squared plus 4y minus 15, 9 minus 4y squared. Okay. Let me rewrite. 4y squared plus 4y minus 15 over 9 minus 4y squared. Okay. In the numerator, we have 15 times 4, which is 60, with a negative sign. So we have 15 times 4, but we need their sum to be 4. So what could be these numbers? Now when they become slightly bigger numbers, it's a good idea to factor them individually and then look into possible solutions, right? So 5 times 3 will be 15 and 2 times 2 will give us 4. Now we are looking for sum of our two numbers P and Q to be equal to 4. One of them has to be negative, right? So one of them will be negative. Okay, so what combination could give you this result? Right? So 5 times 2, if I combine with 3 times 2, which is 6, in that case, we do get 4, correct? So if we have one combination as 6, the other one as 5 times 2, right? Then we do get, but we need positive 4. Since we need positive 4, bigger number is positive, right? So 10 will be positive and 6 will be negative, correct? So these are the two numbers which can help us decompose 4y and then get the result. So we can write this as 4y squared plus 10y minus 6y minus 15 over. Now this portion is difference of squares, and I could always write this as 3 minus 2y times 3 plus 2y. Now in the numerator, the first two terms, we can take 2y common and we get y plus 5. Here we can take 3y common, 3 common, right? Minus 3 rather. So we get again y plus 5. Now we can take y plus 5 common and we are left with the other factor as 2y minus 3. And the denominator is 3 minus 2y times 3 plus 2y. Now is there any factor which you can cancel? Well, 2y minus 3 and 3 minus 2y are the same factors with negative 1. So you could actually cancel them. And you can write this as equal to negative y plus 5 within brackets, right, over 3 plus 2y or 2y plus 3, either way. Perfect. So that is how you could actually cancel and simplify it. But once you do that, you have to state restrictions. And on this, the restrictions are, consider both of them. Y is not equal to plus minus 3 over 2. You see that? So this is kind of important to mention. Right. So I hope you understand how do we simplify a rational expression, and to make it an equivalent algebraic expression, it is important to add restrictions, even if it is not mentioned. If you don't do that, then they are not equivalent expressions. Perfect? Okay. So now we will see how to multiply and divide rational expressions. So I have taken two examples here, one to multiply, the other one is to divide. So let's do the first one, which is we need to multiply 2x plus 6 over x squared plus 7x plus 10 with x squared plus 3x minus 10 over x squared minus 4. Now in the previous case, you must have seen we took a couple of steps to factor. Sometimes if factoring is lengthier, it could be done separately. Perfect. Now in this case, factoring is rather simple. So you can take 2 common here in the numerator. So we can take x plus 3 as the factored form. Denominator, we are looking for a product of 10, sum of 7. 5 times 2 can work for us. So x plus 5 times x plus 2 is good enough. Now here we are looking for, again, sum of 3 but product of minus 10. So one of the numbers have to be negative, bigger number is positive. So we get x plus 5 times x minus 2. See, their product is minus 10 and their sum is plus 3. Denominator is difference of squares. We could write this as x plus 2 times x minus 2. So whenever you are working with rational functions, you have to be really good at factoring, and that is why we had so many examples earlier. Now, once you have factored, it's a good idea to write the restrictions, right? So let's state the restrictions here itself. We say x is not equal to, denominator cannot be 0. So that gives you minus 5, which can make this 0. This is minus 2. This is also minus 2, which we have already included, and that is plus 2. So these are the three restrictions on our example which we are working with. Now to simplify, let's cancel the common factors. So the common factors here are x plus 5 and x plus 5. They can be cancelled. Perfect. Now x minus 2 and x minus 2 can also be cancelled. So we are left with these. So we could write this as 2 times x plus 3 in the numerator, and we have x plus 2 whole square in the denominator, and of course the restrictions remain as minus 5 and plus minus 2 cannot be part of this rational expression. So I hope that step is absolutely clear, right? So whenever you are multiplying, the restrictions include the denominator factors not being 0. Now let's take up the second example, which is based on division. So it's very similar. Let's rewrite this. So we have x squared plus 5x minus 14 in the numerator, and the denominator is x squared plus 8x plus 7. And we need to divide this by x squared minus 4x plus 4 over 3x squared minus 6x. Okay, let's try to factor them. 14, right? 7 times 2. Bigger number positive. 7 is positive. X plus 7 times x minus 2, right? 7, positive 8. 7 and 1, right? So x plus 7 times x plus 1 divided by 4. 2 times 2. So it's a perfect square, right? So x minus 2 whole square over 3x is common here. You're left with x minus 2, right? Now, when you divide and factor, you can see that you have restrictions. And let me write down restrictions here as... Now, there is no need to write the word restrictions. I just wrote it. So let's x is not equal to minus 7, minus 1, 0, and 2. So this is when you are looking only in the denominators. Do you see that part? But see, remember, division is reciprocal of multiplication. So our next step is going to be, we'll flip this. So let me rewrite this. X plus 7 times x minus 2 over x plus 7 times x plus 1 multiplied by reciprocal of this. So we get 3x and x minus 2 in the numerator, and that becomes our denominator. That means something. We have to include this also in our restrictions, correct? However, it is already there. Since it is already there, we are not adding any restriction. But it is kind of important to understand that whenever you are dividing, we are looking for restrictions in both numerator and denominator. Does it make sense to you? Right? In case of multiplication, we are only looking in denominators. The reason is very clear that division is reciprocal of multiplication. So when you multiply, you have to flip it. And therefore, both cannot be 0. You cannot divide by 0. Is that clear to you? Right. Now, let's cancel the common factors. So one of these powers, they get cancelled. Now we have x plus 7 and x plus 7, which gets cancelled. X minus 2, we have another term here, so both of them get cancelled. So we get 3x over x plus 1 as our answer. So we could write this as 3x over x plus 1 with final restrictions that x is not equal to -7, -1, 0 and 2. Is that clear to you? So that is how we can do multiplication and division of rational expressions. And now let's see how do we add and subtract and do their combinations. We'll discuss how to add and subtract rational expressions in this particular video. So these are the 4 examples which we'll cover, and we'll also understand the basic concepts. Rational expressions are very similar to rational numbers, and therefore the very first example which I have taken is to see how do we add 2 over 45 plus 7 over 30. And then we'll see how we can apply the same concept to add the rational functions. So let's begin with the very first one, which is 2 over 45, and we want to add 7 over 30. Now, these are rational numbers where we have ratio of integers, right? One integer over the other integer, and we need to add them. So the concept here is basically to make common denominator, right? So the first step which we look into in such cases is to find the lowest common denominator, right? So we are looking for lowest common denominator. How do we figure this out? Well, we can look into the factors of 45 and 30. Now 45 can be written as 5 times 9, and 9 can be further factored, so we get the factors of 3 and 3, right? So for 45 we have these 3 factors. As far as 30 is concerned, we could write this as 3 times 10, and 10 could be factored as 2 times 5. Correct? So that means that 45 can be written as 5 times 3, which is 3 squared, and 30 can be written as 3 times 2 times 5. Now from these, the lowest common denominator will be, we have 1 5, right? As far as 3 is concerned, we have 2 3s, 3 squared, and then 2. So when you multiply this, we get 5 times 2 as 10, and 10 times 9 as 90, correct? So we get a factor, common factor, which is also the lowest common factor, is multiple, I should say, not factor, lowest common multiple as 90, right? Now, we also say that should be our lowest common denominator. So we have to make both the denominators as 90. How can you do that? Well, we have 2 over 45. We need to multiply this by 2 and also divide it by 2, correct? So to make it 90, which is our lowest common denominator, we have to multiply and divide by 2. Similarly, for 7 over 30, we need to multiply and divide by 3, right? So that gives you as equal to 4 over 90 plus 3 times 7, which is 21 over 90. Now, when we have a common denominator, we can add the numerators. So we say it is 4 plus 21 over 90, and so the result is 25 over 90. Now, 25 over 90 can also be simplified, right? So we can divide both by 5 and simplify the result. So if I divide by 5, what do I get? We get 5 in the numerator, and dividing 90 by 5 times 1, 48, right? So we get our answer as basically 5 over 18. So as you see, the steps being followed are that we have to somehow get the lowest common denominator. Once we get it, then both the rational numbers in this case are written with the same denominator, and the numerators are then added. And if possible, then we do simplify it and write down our answer, right? So in this case, we get our answer as 5 over 18. So I hope the steps are absolutely clear. We are now going to follow these steps in our examples and understand how do we add and subtract rational expressions. So I hope this concept is clear, right? Now we are going to apply the strategy learned in this particular case. We'll simplify and state restrictions. 1 over 2x squared plus 2 over xy minus 3 over 5y squared. Well, for any rational expression, the denominator cannot be 0. So the restrictions here are that x is not equal to 0 and also y is not equal to 0. So these are the two restrictions for us. So first thing, let us state the restrictions. Now, let's see. What is we need to add and subtract these. Let me rewrite them. We have 1 over 2x squared plus 2 over xy minus 3 over 5y squared. Now, as far as the lowest common denominator is concerned, we have x squared, we have y and y squared. So the lowest common denominator in this case is going to be what? 2 and 5, right? They get multiplied. So lowest common denominator is 10x squared y squared. Correct? So that becomes the lowest common denominator. Now, to make each term with this lowest common denominator, what should we do? We have to multiply both numerator and denominator by the same thing. So we have here 1 over 2x squared, and to make it 10, we have to multiply by 5 and divide by 5. We need y squared also, so we'll multiply and divide by y squared, right? Same thing is done on the other two terms also. So we have 2, and here we have x times y. In this particular case, to get 10, we have to multiply and divide by 10, and as far as the variables are concerned, xy, correct? The third one, here is 3 over 5y squared. To get 10 in the denominator, we have to multiply and divide by the number 2, and x squared, y squared, x squared is missing, so we'll multiply and divide by x squared. So when you do that, you do get common denominator, and now the common denominator for us is 10x squared y squared, correct? Numerator gives us 5y squared, and that gives us plus 20xy, and here we get 3 times 2 as 6x squared, correct? So that becomes our numerator, and this is the result of adding and subtracting these rational functions, correct? This cannot be further simplified, and therefore we are going to leave it right there. So I hope that makes sense. And the restrictions, as I mentioned earlier, here x is not equal to 0 and y is also not equal to 0, since division by 0 is not permitted, correct? Now let me also write a general rule here. So if we have a rational function of the form of px over qx, and we are adding or subtracting some other rational function from it, let's say rx over sx, then in that case, in general, we could write it kind of like this. We could multiply the denominators if they don't have anything in common, right? And then we could write this as px times sx plus or minus rx times qx, right? So that in general is to be done. And note here that qx and sx should not be equal to 0, and that leads to restrictions. Is that clear? So that is a general rule. Now we are going to follow these steps to solve the next two examples. The equation here now is 2 over 5mn minus 3n plus m squared over 2m cubed plus 3. So let me rewrite this. We have 2 over 5mn minus 3n plus m squared over 2m cubed plus 3. Now see, what is the common denominator here? So let's begin with the numbers 5 and 2. 10. So 10, right? So then we get 10. M cube, right? So that is 1. And as far as n is concerned, we have n. So that becomes our common denominator. Perfect. Now, to get this, what should I multiply the first term with? We already have 5 times mn. So I have to multiply this number by what? To get 10, I have to multiply this number by 2, right? Because 5 is already there. So by 2. And m square, right? So m square. We have n that will result into the same denominator, correct? In the second case, we have 2m cube. Now that means we need 5 times n. So we'll multiply 5 times n with 3n plus m square. Is that clear to you, right? Plus 3 times, here the denominator is 1. So we'll multiply by all of them, which is 10 m cube n. Does make sense to you, right? And now let's open this bracket. So we get 4m square minus 5 times 3, 15n square. Change the sign. 5m square n, and then here we get plus 30 m cube n, right, over 10 m cube n. Is that correct? So that is how we could get our result. Well, if you want, you could arrange them in an order with highest degree of m first, right? So you could write this as 30 m cube n, and here we have minus 5 m square n. You could take m common anyway, plus 4m square minus 15n square over 10 m cube n. So that will be the simplified form. Now let us also add the restrictions, correct? So what are the restrictions here? Denominator cannot be 0, correct? So that gives us restrictions as m is not equal to 0 and n is not equal to 0. Perfect. So that is how we are going to do it. Now here is the last example, slightly more complicated. I would like you to do this and then you can take up unit test on this particular chapter. I hope that will make sense. Once you have done, then you check with my solution. We need to simplify and state restrictions for x plus 5 over x square minus 2x minus 15 plus 5x minus 2 over x square minus 5x. Now the first step is to find the lowest common denominator. So let's factor both of them and then see what could be the lowest common denominator, right? So we could write this as x plus 5 over x square minus 2x minus 15. That means we are looking for a product of 15 and sum of minus 2. So 3 times 5 can work. Negative means we have to use x minus 5 times x plus 3. So that will give us negative 2x, right? Plus 5x minus 2. So the numerator 5x minus 2, denominator x square minus 5x. X is common, so we'll take x common and we get x minus 5 in our denominator, right? So the first step normally will be to factor. And now we'll find the lowest common denominator, right? Now in this case, the lowest common denominator is, so we have these factors. Well, x is alone, so x1, and then we have x minus 5, and we also have x plus 3. So that will become the lowest common denominator. Now in the first term, in the denominator, x is missing. So we'll multiply the numerator by x. So we get x times x plus 5, right? Plus. In the second term, the factor x plus 3 is missing. So we are going to multiply that by x plus 3. Is it clear? Perfect. Now, whenever you do this operation, we like to keep the denominator in the factored form. I like you not to ever expand the denominator, right? But you need to expand and simplify the numerator. So we'll keep the denominator as such. Numerator, let's expand it. We get x squared plus 5x plus 5x squared minus 2x plus 15x minus 6, right? Now that is what we get. We can now combine the like terms, okay? So let's write this as combining the like terms. The denominator here is x times x minus 5 times x plus 3. As far as x squared is concerned, we get 6x squared. 5x minus, well, 5 plus 15 is 20. Take away 2 is plus 18x. The number is minus 6. So that is what we get, right? So if you want, you can factor the numerator taking 6 common, right? So we could write this as 6 common. We get x squared plus 3x minus 1, and the denominator is x times x minus 5 times x plus 3, correct? So that is the simplified form. Now important part here is also to write the restrictions. So the restrictions is that the denominator cannot be 0. So we get x is not equal to 0, then this factor will be 0 for 5 and this will be 0 for minus 3. So these 3 becomes the restrictions. And that is the simplified form. Is that correct? So that is how we have to do addition and subtraction of rational functions. Taken 2 examples where we are going to multiply and divide rational functions. The question here is to simplify and state any restrictions on the variables. A square minus 1 divided by 1 plus b times 1 minus b square divided by a square plus a divided by b cube minus b over a. And b is x square minus y square divided by 4x square minus y square divided by 2x plus 3y over 4x square plus 8xy plus 3y square times x over x plus y. You can always pause the video, answer this question, and then look into my suggestions. So let's begin with part A first. We are given a square minus 1. It could be factored as a plus 1 times a minus 1, right? Denominator is 1 minus b times 1 minus b square can be written as 1 plus b times 1 minus b divided by, here we can take a common, so we get a plus 1 as the other factor. Then we have divided by b cube minus b. So we can take b common, right? So we get b square minus 1 over a. Now, whenever you have to write restrictions for division, you have to write restrictions of both numerator and denominator, right? So let's write the restrictions first. Restrictions are so first is b cannot be equal to 1. So let's write with b not equal to 1, right? Here b cannot be equal to 0 and b is not equal to even minus 1. So b is not equal to 1 plus or 1 minus. As far as a is concerned, a is not equal to 0 minus 1. This is also 0, right? So 0 or minus 1. So these are the 5 restrictions on the variables. Now, multiplication should be used for division. So we'll rewrite all this and then cancel the common factors. So what we get here is a plus 1 times a minus 1 over 1 minus b times 1 plus b times 1 minus b over a times a plus 1 multiplied by, so a over b. Now this can be factored and written as b plus 1 times b minus 1. Clear? Correct. Now let us cancel the common terms. 1 minus b and 1 minus b gets cancelled. A plus 1 and a plus 1 gets cancelled. A cancels with a. We have 1 plus b and b plus 1 which gets cancelled. Okay, so now we are left with a minus 1 in the numerator and b times b minus 1 in the denominator. Correct? So that will be our answer. So what we get here is a minus 1 over b times b minus 1. Correct? So that becomes our final result. And of course the restriction here is that a is not equal to 0 and minus 1 and b is not equal to plus minus 1 and 0. Correct? So that is how we are going to solve this question. And now let us take up part B of this question. So in part B, we have x square minus y square over 4x square minus y square divided by 2x plus 3y over all this times x over x plus y. Now we need to factor this trinomial, so it's a good idea to take this up separately. So let's try to factor 4x square plus 8xy plus 3y square first. We're looking for a product of 4 times 3 which is 12 and sum of 8 which is 6, right? So 6 times 2 can work for us. So we could write this as 4x square plus 6xy plus 2xy plus 3y square. Now group factor, so we have 2x common. So we have 2x, we get 2x plus 3y plus here y is common, so we get 2x plus 3y. Now we could write this as 2x plus 3y as one factor and the other factor being 2x plus y. So that is how you're going to factor this denominator. Others are relatively straightforward. So let us now write this rational function in factored form. Difference of squares. So we could write this as x plus y times x minus y divided by, this is also difference of squares, 2x whole square, right? So we could write this as 2x plus y times 2x minus y. So that is the first term. Now division. We'll write straight away multiplication, take it in the numerator, the factored form, which is 2x plus 3y times 2x plus y divided by 2x plus 3y, right? So as such, times we have x over x plus y, correct? Now, before cancelling, let us write down our restrictions. Restrictions are, from here if we begin, x is not equal to minus y over 2, right? So x is not equal to minus y over 2. Now here x is not equal to plus y over 2, so we can say plus and minus y over 2, correct? Here x is not equal to minus 3 over 2y, so minus 3 over 2y, that becomes another restriction, and x is not equal to minus y and also not equal to minus y, correct? So that is another one. Now whenever this division is there, we have to write restrictions of both numerator and denominator, right? So here the restriction is minus 3 over 2y, but this we have already taken, correct? And here we have minus y over 2, which we have also considered, right? So no additional restrictions since these have been already covered. Perfect. So now let's write this after simplification. Cancel the terms which are same in numerator and denominator, right? So we have these terms which are exactly same. X plus y cancels with x plus y, and the rest is our answer. So we get x times x minus y over, the term left is
2x minus y in the denominator, right? So that is your final answer with restrictions. Let me rewrite. So we are writing x in terms of y. X is not equal to plus minus y by 2 minus 3 by 2y and minus y. Do you see that? So that is how we should be answering such a question. I hope this helps to understand the concept. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.